Okay, so this is for the homeworks at 10.4 and 10.5. This is about hypothesis testing with regard to the standard deviation. So to do this, the first thing is to find the critical values. This is pretty straightforward for part A. You're just going to click here. You'll look for 14 degrees of freedom. That would be 14 here. And then you want A to be 0.05, so that one will match exactly. So that would be, in this case, 23.685. You enter that and it'll go to part B. For part B, it gives you alpha as 0.1. It's a left-tailed test. Because it's left-tailed, you have to do the complement because this is a right-tailed test. So it says area to the right. So we're going to do 1 minus 0.05, which is 0.95. That's this one. And it wants, n is 24, so we use 23 degrees of freedom, one less. So we go down to 23. We're at 0.95. The answer here will be 13.091. Now for the last one, you have a little bit more work to do. N is 30, so that means the degrees of freedom is 29. And alpha is 0.05. So we're looking at this row. Your answers will be in this row. And you're going to have two of them because this is a two-tailed test. To figure out what they are, you do 1 minus alpha over 2. So this is 1 minus 0.05 divided by 2, which is 1 minus 0.0025, which is 0.9725, I think, or 9775. And then for the other one, you have 0.05 divided by 2. That's just 0.0025. So if you put these two answers from row 29, you will get the right answer for this. So if we look, that's this one, 0.9. Oops, did I put 977? Sorry, it's 975. I subtracted wrong. Sorry, this is not this. This is 0.975. This is 0.025. Sorry, that's better. Okay, you put those answers from that chart on row 29. Remember, it's one less degree of freedom than there are n, and that gives you your values. So that's how you do these ones, and separate them with a comma, otherwise the program will complain. For the next one, let's run through this. So you have to figure out what chi-squared is. The formula for that is the following. It is n minus 1 times s squared over sigma squared. It's really easy to do. So if we look at this, problem, they give us n is 17, so we're going to plug that in. So we've got 17 minus 1, and they tell us right here sigma, or s is 1.3. And sigma from above is also 1.3. That's strange. Well, these are just going to cancel, so that leaves us with 16. So let's put 16 here and see what it does. It's the first time I've seen that happen, ever. It worked. Okay, now it says if the researcher wants to determine the test hypothesis with significance, determine the critical value. This is a right-tailed test. Actually, no, this is left-tailed, right? Because this is less than. So we're going to do 1 minus that. That's 0.9. And then we want 16 degrees of freedom. So you're going to use your table from the last one. I don't have one with me. So let's look. Chi our table. Okay, let's go there. So we want 0.9 and 16. Oh, these are too big. 16. Oh, they don't have it on there. This one. 0.9 and 16. That's 9.312. Let's hope that works. 9.312. Okay. It's left tail, don't forget that. Well, that means it's either C or B. I'm assuming it's C, because 1.3 is not very large. Yeah, it's C. And then, will they reject it? Well, the value we got was 16. The critical value is 9. So that means this X naught is bigger than chi of 9.0. So will they reject it? No, because chi naught is greater than the critical value. Okay, so that's just the case when it's that. We usually use the p-value rather than that. That's just another way of doing a hypothesis test. So let's do another one. If we're going to do this one, we have the following. I'm going to determine this value really quick. So we're going to do n minus 1, which is 26 minus 1, which is 25, times the s, which is 66.3 squared divided by 70, the hypothesis test value squared. We get 22.43. Okay, now is the tricky part. So here's what you're going to do. To do this with a calculator, you're just going to go second distribution, and you're going to go to chi-square. There it is, chi-square CDF. Okay, the lower and the upper. So this is a less than. So we need to make sure that it is a upper bound, that the value that we found here is an upper bound if it's less than. So we're going to leave this, we can put negative 999 here. We just want to make sure we get everything to the left. The upper bound is going to be 22.43. And the df is going to be the degrees of freedom, which is 26 minus 1, which is 25. The n minus 1. We enter that, we get point. Let's do this real quick. This is 0.3891. It says 3 decimal places. 9. Okay. So check the answer. Very good. We got it. All right. Now, since the p-value is greater than, because 0.389 is greater than 0.10, they will not reject the null hypothesis. So we accept that it's actually, we can't, there's not enough evidence to support that it's less than 70. That's all that means. Okay. That's how you do this one. And then basically the rest of these are the same as that one. You do have to do your null hypotheses. Remember, when you're doing null hypothesis, it's always when it's equal. You have to figure out which thing they're talking about. Are they talking about mean, standard deviation, or proportion? Proportions, obviously, they give you numbers to deal with. Means, they give you actual means. And then standard deviations, they'll give you a standard deviation. And then you just have to be able to interpret the hypothesis from all of that. So if you go through these, just figure out which one it is. Remember, there's only a couple things you use on the calculator for these hypotheses tests. If it's one thing, it's either one prop z test, it's either z or t test, depending on if it's a sample and you know the mean. If it's a sample and you know, if it's a sample and you know the standard deviation of the population, you use a z test. If it's a sample and you don't know the population standard deviation, then you use a t-test. And so make sure you keep that in mind. That's how you'll know which one you use for the mean tests. And then finally, if it's a standard deviation, you're going to end up using the chi-squared. You use chi-squared to do standard deviation tests, and then eventually we'll use what's called an f-test when we do two standard deviation checks. So like if we check two standard deviations amongst each other to see which one's bigger or less, or if there's some kind of hypothesis test we're going to do. I hope this helps, guys. Have a good day. Take care and goodbye.